Welcome, everyone. My name is Mary Turner. I'm Director of Training here at Breault Research Organization, and I will be presenting this webinar this morning. There are also a couple of people from Breault who are listening in, so you will notice that you have a little chat box that's available to you. If during this presentation, if you have some questions that you have, if you'd like to enter them in that little chat box, someone from Breault will either get back to you during the course of this presentation or shortly thereafter. To answer those questions, I will let you know that I probably will not be paying attention to that little chat box. I'm looking at a different monitor right now, so I can keep within my, I believe I'm allotted 23 minutes to get this presentation done, so I'm pretty much going to concentrate on this. After the presentation is over, for all of you who are in attendance, a copy of the presentation will be available. And again, if you have any questions that come up at any point after regarding this, please get in touch with us. But with that said, let's talk a little bit about the subject at hand, which is setting up a parametric study in Apex. And what we're going to talk about exactly what we mean by a parametric study, and then the process for applying a parametric study, and exactly what does a parametric study allow you to attain within the Apex environment. So the first question, of course, is what do we mean by a parameter study? And a parameter to me is, in the context of this discussion, is basically any defining parameter, shouldn't use the same word when you're describing it, but any number that defines a property of your system. It might be a distance. It might be a focal length or radius of curvature, but any of the numbers that you would define to describe your system. And for those of you who think about this world in terms of optimization, then yes, it's effectively an optimization variable, but we're trying to avoid the problems, at least initially, associated with optimization, which is that optimization of illumination systems tend to get bogged down because where do you start? How many possible acceptable solutions whose local minima is sufficient to meet your application are there, and how do you even go about deciding where you're going to do the optimization? So the result of a parametric study, the end goal is to do a more rigorous optimization. But what a parameter study is designed to do is to help you decide what the initial starting point should be. And as part of this process, what you'll be able to do is analyze some of these different parameters, these different numbers, to see which have the greatest impact on the design's performance, and in particular, which combinations of parameters show the most promise in leading to a viable solution. So if you want to think about it on the most simple level, a parameter is almost like a pre-optimization. It helps you know where to go, where to start. And as a simple case here, this is a system I set up to do a parametric study, and I allowed two, in this case, dimension variables to be perturbed in a fixed amount. And what we see is the result, in this case, of the total energy on a target as a function of various combination of variable values. So the difference between a parametric study and an optimization is rather than making continuous potentially slight changes to the value of a variable, we change the value in fixed steps and see how that affects the performance of the system as a whole. And what you can see here is that in this particular case, I have what look to be four very, very similar global minima, if you will, or optimal solutions. And I will say the reason this one looks a little bit smaller is simply because of the range of parameters I selected. If I allowed one of them to have a slightly wider range, I would have had effectively four very uniform peaks. So now I can look at this data and say, okay, well, all of these give me about the same solution, but this one is smaller, or this one fits better into my available volume. I can now ask other questions that can lead me to a better result. So what are the requirements to do a parameter study? Again, it is very similar to optimization. So what you're going to need to start off with, which parameters are you allowed to change? Position of your, for instance, the position of the LED, the radius of curvature of the reflecting surface, the conic shape of the surface, positions, spacings, any numerical value that can be entered into SOLIDWORKS can be used as a design parameter that can be modified. You also need to define some type of performance metric or performance metrics that you want calculated for each system modification. Okay? You might think of these as sort of a merit function, but again, no optimization is being performed. Apex will simply calculate one or more values as a result of each of these iterative changes and present that information to you. You also can apply constraints, which allow where design forms that violate the constraints will be indicated. Again, no optimization to move away from the violating condition, but it will be indicated when some type of dimensional constraint, whether it be an area, a length, a volume, is violated by one of these iterative designs. So now let's talk about the process of setting up the design study, the parameter study. What you need to do is to have any Apex assembly file. Ray tracing is going to be performed, so it must be an assembly file. That file will include all of the relevant geometry that needs to be included in the system, the geometry that can interact with the light, and any sources that are necessary. I will, as an aside, say when it comes to sources, as we know from doing illumination optimizations, the number of rays you trace will significantly affect the accuracy, the error in your calculation. But don't start with massive number of rays in your source. Just to start with the interim design, start small and add rays as necessary. You should always verify the design first by performing a ray trace. If the rays can't be traced through the system, then the iterative study isn't going to be able to provide you any information. So this is just to make sure that you have a valid, viable system before you try to do the parametric study. Then what you'll do is to identify the parameters that you wish to perform this iterative change over. And you can use any number of parameters. But again, start small and build up. And then also, even as you're starting small, compare how different parameters interact with each other. Just putting a bunch of parameters in there at once and iterating over all of them simultaneously really doesn't give you as much information as looking at them in small sets. The types of parameters that can be iterated, as I mentioned, have to be a dimension that has been defined in SOLIDWORKS. So it could be a driving dimension. It could be a spline handle. You can also use equation-driven parameters. So if there's a parameter that you haven't specifically set as a numerical value within the SOLIDWORKS environment, you can define a line segment that relates to that dimension and allow that the value of that line segment or the length of that line segment to be part of your parameter study. Again, you can add constraints if you desire. Constraints are very useful in optimization because they will drive the design away from violating solutions. Since we're not doing an optimization, this will simply give you a flag. But basically, constraints are based on any SOLIDWORKS sensors, and the most common ones, of course, would be maximum or minimum length, area, or volume to be allowed for the design. And then you'll need to select the desired measurements, effectively optimization goals. These can include power total power calculations, the intensity or irradiance distribution, and these can be both radiometric or photometric, and we will take a look at many of the ones that are available as we continue on with this discussion. Additionally, you can perform multiple parametric studies and save them with your design. So when you come back and reload the design tomorrow or 6 months from now, that information is all available to you, so you can go back, reanalyze the data, make changes, and continue on with your design work. You can also start by using a particular number of parameters or a particular set of parameters, and you can add more, enable and disable parameters at different stages of an analysis if you desire to do so. But again, the key is, and my recommendation would be at least, to initially look at interactions between a small number of parameters and then add in others if you find that you're not approaching a viable solution space. But you should be able to determine those parameters that have the greatest impact on the overall performance of your system. And then the result of each iteration will be saved. So for each value associated with any of the parameters, the result, including all of the values associated with it, the goals, will be saved, can be recalled, analyzed, and then you can do further optimization if you wish. But all of the data about all of the individual parametric studies will be saved for your later use. So now we'll go into a little bit more detail looking at how things are set up within the APEX environment. And as mentioned, the study parameters are any dimensions that are defined within SOLIDWORKS. So I can have a sketch dimension, or I can have a mate dimension, as I have right here. And again, dimensions, spline handles on spline curves are also available. Obviously, be careful with spline handles, because as you move those around in SOLIDWORKS, you find that sometimes you have geometry that violates physical reality, and SOLIDWORKS gets upset. But fortunately, within the APEX parameter study, you will be able to limit the amount of changes to each of these items. Okay? But when you select, in this particular case, you can see that the dimension 6 is highlighted. You'll just click to accept that as a study parameter, and it will be entered into the table of data. So here's my added, and it has simply the name variable 1 and then 2, 3, 4, etc. You can, of course, apply a name that makes more sense to you. The SOLIDWORKS dimensional name is also automatically brought along as well. And here you can see the original value. You can set a minimum and a maximum. And then there's an increment and a number of steps. Okay? You can choose one or the other, and then APEX does the math for you. So for example, down here, if I said I wanted to go from a minimum of 1 to a maximum of 11 in an increment of 1, it will be 11 steps. But if I said I wanted to go from 1 to 11 in 5 steps, it would mean an increment of 2.5. So as you're setting this up, you can decide how many iterations of the process you wish to suffer through for each step of the process. And the constraints basically are where you get to set a limit. I don't want something to exceed or to be less than some amount. And as I mentioned, linear dimensions, volumes, and surface areas are probably the most common constraints. You don't want the total volume encompassed by your reflector to exceed some particular amount or some other type of constraint. Again, because this isn't an optimization, there's not going to be a penalty function applied because the constraint is violated, because we're simply calculating what is the total power, what is the irradiance distribution. But in the results table at the end, you will see if it will be flagged to indicate this particular solution violated your design constraints. Okay. Now, in terms of optimization, which of course is the end goal of this process, if you have a violation to the constraint, it will impact the merit function. So a violation of the constraint will increase the total value of the merit function, which will drive the optimization towards a non-violating system. Because the parameter study looks only at specific solutions, violating systems won't be changed, but they will be indicated to you, so you take that into consideration when you're deciding which result of this parameter study you want to look at further. Now, the goals or the measurements you want Apex to do, very similar to design goals that you would do to create a merit function for optimization. But again, there's no iterative type optimization being done. You can simply choose the appropriate goal. So although it's clipped off here, you can notice that I've highlighted my target, the front face of my target in the little LED CPC array assembly file many of you are familiar with. If you've taken my class or looked at the website, it's one of my favorites. You all know that. But I've highlighted this face, and then I can do any number of measurements. If I want to know the total power on that surface, I can do that. I can get information about the intensity, irradiance, the radiance, photometric power, luminous intensity, so radiometric or photometric information. Just need to select the item or items of interest and add them down here as among my goals. Now, once I've selected what my goal is, I'm going to see displayed a window, and this is basically in this particular case, this defines the size over which the measurements are going to be made. And then I can do a measurement over the entire window, which will be defined by its boundaries as listed here. I can also define a specific point. I can define a line or a region. I can define a polygonal area, a circle, or an ellipse, or as I mentioned, the entire window. And these are selected by simply choosing the appropriate icon up here. If I, for example, chose circle, and again, my window is cut off a little bit, I'd be able to put the X and Y coordinates of the center as well as the radius. So I have a great deal of flexibility in defining the region over which I wish to capture the energy. And by default, there will be a simple adjacent pixel averaging applied because, as we know, there's lots of statistical noise in illumination designs. But you can also apply different types of averaging to the data if you prefer, and that would be listed in this drop-down area here. But again, I should have shrunk my window down to show, but we're going to see the whole setup in a couple of minutes. So if it's cut off here, don't worry about it. You will see it in a few moments. Okay, so in this particular case, if I've selected the power, all the power is a total value over the designated window, and in this particular case, my source power was 1, so that's what my target is. When it comes to intensity, I have options. Do I want the average, the sum, or the standard deviation? So if I want to minimize the change across all my pixels on my surface of interest, I would want to drive my standard deviation, for example, to 0. So those are some of the options available to you. And again, with the case of power, there are no options because it's simply a total value. It's a simple one number. It's the total power in the area. Intensity, irradiance would have other options available to you. And again, you can set the target. You can apply a weighting to them. But again, for the parametric studies, that is not as applicable as it is to optimization. After you go through the iterations, what you're going to do is see the results presented in both tabular as well as there are graphical forms, as you saw previously when I showed you the 4 peaks from that one design solution. If you highlight one of the trials, it will update the SOLIDWORKS model to match that particular design. And then you can do further analysis. But all of this trial data is going to be saved with the file, so you can come back and look at the data at some time in the future without having to redo the study. And you can look at a graphical analysis of any or all of the trials. The numerical data can be exported if you want to do some post-processing, but you can create picture plots, you can create goal plots, false color plots for all or just one of the trials. So lots of graphical options available to you. So, and here are a couple of the results, and this was the picture basically from earlier in this presentation, where I simply want to see in my case, the total power as a function of variable 1 and variable 2. And in this particular case, I just had a grid of rays, and I can see what the distribution of those look like. So before we close, what I'd like to do is to look at a quick example. And to save a solution, all you have to do is save the file. Everything is saved with the file. If you update the file to match one of the trial solutions and you save the file, that becomes the file that will be there when you open, but all trial solutions will be included as a data file that you can simply reopen the parameter study. So what I'd like to do now is look at a quick example. And in this particular case, this is about as simple as it comes. We have an LED, sort of representing an old-fashioned style LED, reflecting cup. Okay, the 40 degrees is the angle of the cup, and the 8 is the position of the cup relative to the base of the volume. Okay, so what I'm going to do is rotate this around so I can look at it, straight on. And I've gone to the Design tab, and you'll notice if I click on the Parametric Study, I come to this Parametric Study page. And for example, I can come over here and, okay, what I'm going to do is select those two parameters. So I'm going to come down and add a study parameter. And I've selected this value, which is a dimension. Come on. And I double-clicked. So there is that parameter. And I'm going to add that to my table. And you'll notice a range of values. And so we can go from 6, okay, to 12. And we can set the number of steps, and let's cut down the number of steps to 4. And you'll notice when I change the number of steps, the increment changed as well. And then, okay, so let me save all. That's fine. So we have this dimension selected. I'm going to add a study parameter. That is this dimension. Come on, let's go here. And I'm going to add that. And again, we have the angle. And so, for example, I can go from 30 degrees to 60 degrees in 3 steps. Now, maybe what I want to do is to maximize the energy on my target. So if I just select this face of the target, and I'm not going to worry about constraints right now, I'm going to add a goal. And you'll notice it knows that I had pre-selected that face. But instead of intensity, I want to do a total power calculation. I'll just click on OK. And now here's the pop-up that allows me to set what part of this face I'm looking at. And again, there were points and lines, regions, polygons. I'm going to use the total window. So I'll just click on the total window so it knows the size. If I wanted to change that, I could also come in and hand enter the data if I desired. And here's where I can change the averaging from the simple adjacent pixel tools. I'm going to, for our purposes, that'll be fine. And now I'm just going to add this to my goals. And close that for now. And my target is 1. Power from my source. I want all of it there. And since it's my only parameter, the only goal, target weight of 1 is fine. And now all I have to do is click the Run button. And what I'd like to do is to get this in a better view, but you can see that these numbers are changing, updating as we go through each cycle. This is set up to do a total of 12 different sets, and you'll notice that this will update as we go through, and you can see the numbers changing. Oops, sorry, didn't mean to click on that. So this is the basic process, and I wanted you to be able to see the process at work, but I don't want you to have to sit here and let me go through this. So what I'm going to do is, that's fine. I can now choose to look at the results view. I'm going to come up here and look at this, and you'll notice as I select different trial solutions, you can see that in this particular case, we're changing the angle first. So this value, the height stayed the same as we iterated through the angle. Now the height changes, and we're going to iterate through the angles again. But I can select any of these. I can analyze them. But the key is if I come up here and do a file, save everything. And then close. When I reopen the file, and go back to the Design Study page and choose my Parametric Study, all of that data is available to me. And I did one study, but I can duplicate studies, so most of the things are the same, and then simply change maybe the parameters. I can add additional studies, but again, this is a way to allow me to decide where I should start my optimization. So thank you very much for your time today. Again, if you have any questions, we would be glad to answer them. And I will be making a copy of this presentation available to be distributed to you sometime today. So thank you very much again, and this concludes today's presentation.